On February 4, 2025, the USS Preble DDG-88 made headlines as it successfully deployed the HELIOS high-energy laser with integrated optical-dazzler and surveillance laser weapon system, marking a significant milestone in U.S. naval defense technology. Developed by Lockheed Martin, HELIOS is a cutting-edge solution that transitions directed energy weapons from theoretical concepts to operational capabilities, enhancing the Navy's defense against a range of modern threats including drones, fast attack craft, and potentially short-range missiles. Overview and development timeline. The HELIOS program began in 2018 when Lockheed Martin was awarded a $150 million contract to develop two systems, one for land testing and another for naval integration. By 2020, the project passed its critical design review, enabling the start of integration and testing. Sea trials commenced in 2021 at Wallops Island, Virginia. The culmination of this development process was the successful installation of HELIOS on the USS Preble in 2024, where it demonstrated its capabilities by engaging aerial targets. Key features. HELIOS boasts several advanced features. Multifunctionality. It combines high-energy laser capabilities with an optical dazzler and advanced surveillance, enabling both hard kill destruction of targets and soft kill disruption of enemy sensor strategies. Powerful operations. The system operates initially at 60 kilowatts with potential scalability up to 120 kilowatts. This allows for virtually unlimited firing capacity as long as power is available, significantly reducing logistical burdens associated with traditional munitions. Aegis integration. HELIOS is designed to seamlessly integrate with the Aegis Combat System, enhancing overall combat effectiveness and enabling coordinated responses to incoming threats. Testing and operational readiness. The U.S. Navy's Center for Countermeasures has conducted extensive testing of HELIOS, demonstrating its ability to successfully engage unmanned aerial vehicles (UAVs). The operational readiness of HELIOS aboard the USS Preble signifies a robust commitment to advancing directed energy weapons within the fleet, with plans for future deployment of higher-powered systems such as the 150 kilowatt laser weapon system demonstrator LWSD. Strategic implications. The deployment of HELIOS reflects the U.S. military's broader strategy to counter evolving asymmetric threats while maintaining cost-effective defense solutions. This initiative comes at a time when several nations, including Israel, China, and Russia, are also advancing similar laser technologies, emphasizing the urgency for the U.S. Navy to remain competitive. Conclusion. The introduction of the HELIOS system aboard the USS Preble is a pivotal moment in naval defense, indicating a shift towards high-energy laser systems in operational contexts. Its successful deployment and testing are poised to redefine naval engagements and enhance the U.S. Navy's capacity to address modern threats shaping the future landscape of maritime warfare. As the integration of such technologies evolves, the implications for naval strategy and international security dynamics are profound. Source summaries. 1. Source 1 Army recognition. This source highlights the operational capabilities of HELIOS, its integration with naval systems, and the developmental timeline from inception to deployment. 2. Source 2 Bulgarian military focuses on the technology's implications for naval strategy and emphasizes the competitive landscape of directed energy weapons among various nations. 3. Source 3 The War Zone provides insights into the real-world applications of HELIOS and discusses the challenges faced in deploying laser technology effectively in complex military environments. In summary, the HELIOS laser weapon system represents a transformative step in naval defense, showcasing the U.S. Navy's commitment to leveraging advanced technologies to meet contemporary security challenges. The HELIOS high-energy laser with integrated optical dazzler and surveillance laser weapon system aboard the USS Preble DDG-88 represents a significant shift in naval warfare technology, transitioning from theoretical concepts to practical applications. This deployment is not just a demonstration of advanced technology but also reflects a broader strategic evolution in military capabilities and international defense dynamics. Key counterintuitive insights. 1. Unlimited firing capacity versus traditional munitions. A common assumption about weapons systems is that higher firepower correlates with greater logistical demands, particularly regarding ammunition. However, Helios operates on a fundamentally different paradigm. Its laser technology allows for virtually unlimited firing capabilities as long as electrical power is available. This contrasts starkly with traditional munitions, which require extensive resupply chains and storage. This seemingly paradoxical advantage positions Helios as a more sustainable option in prolonged engagements, particularly in scenarios where resupply could be hindered. 2. Operational versatility. Helios combines both hard-kill physical destruction of targets and soft-kill disruption of enemy sensors capabilities. This multifunctional approach might suggest a compromise in effectiveness, as systems often specialize in one role. However, the integration of these capabilities allows for a more nuanced response to threats, enabling naval forces to adapt dynamically during engagements. The ability to switch between offensive and defensive modes without the need for traditional ammunition opens new tactical avenues, contrary to the expectation that a system must excel in one area. 3. Real-world challenges versus perceived capabilities. While the technology demonstrates advanced capabilities, the challenges associated with deploying laser systems in combat conditions are often downplayed. For instance, while the Helios system can engage drone targets effectively, its performance is impacted by atmospheric conditions which can degrade laser effectiveness. This highlights a counterintuitive reality where the hype surrounding laser weapons may not fully align with their operational limitations, suggesting that despite the advanced technology, their role may be more supplementary than primary in complex combat scenarios. 4. Global competition and technology transfer. The rapid adoption of laser technology by various nations, including Israel, China, and Russia, suggests a burgeoning arms race centered around directed energy weapons. This global competition challenges the notion that advanced military technologies are solely the domain of the United States or other historically dominant military powers. Countries with lesser traditional military capabilities are investing in laser technology as a cost-effective means to enhance their defense systems, indicating a shift towards asymmetric capabilities that could redefine power balances in regional conflicts. 5. Funding and development challenges. Despite the significant funding allocated to directed energy weapons, averaging $1 billion annually, there is a stark contrast between resources dedicated and the practical deployment of these systems. Many projects have faced delays or cancellations, revealing a disconnect between military ambitions and operational realities. This situation raises questions about the effectiveness of current military procurement processes and the ability to transition from research and development to field-ready systems, countering the expectation that funding guarantees operational readiness. 6. Integration with existing systems. Helios's capability to integrate with the Aegis Combat System suggests a seamless enhancement of naval defense, which might imply that existing systems are obsolete. Instead, Helios complements and enhances traditional naval defense measures, revealing a counterintuitive notion that advanced technologies do not necessarily replace legacy systems but rather work in concert with them to create a more robust defense posture. 7. Perception of laser weapons in naval strategy. There is a prevalent belief that laser weapons are primarily futuristic concepts with limited immediate application. The operational deployment of Helios challenges this notion, showing that such technologies are not just theoretical but are being integrated into current military strategies. This suggests a shift in naval warfare paradigms where laser systems can play a critical role alongside conventional weapons in addressing contemporary threats. 8. Public perception versus military utility. The portrayal of laser weapons in media often emphasizes their capabilities in a sensational manner, leading to inflated expectations regarding their effectiveness in combat. Real-world experiences, including the limitations of current laser systems, illustrate that while they are innovative, they may not fulfill all operational requirements. This discrepancy between popular perception and military utility underscores the need for a more measured understanding of how emerging technologies fit within the broader context of military strategy.
Conclusion.
The HELIOS system aboard the USS Preble signifies not just a technological milestone but a deeper shift in naval warfare strategies and the nature of modern military engagements. As nations invest in similar technologies, understanding the counterintuitive aspects of weapon systems like HELIOS, ranging from operational capabilities to logistical advantages, will be crucial in navigating the complexities of future conflicts and international defense relations. The implications of these advancements extend beyond military applications, reflecting broader themes of sustainability, cost-effectiveness,
and strategic adaptability in an increasingly uncertain global landscape.
The HELIOS high-energy laser with integrated optical-dazzler and surveillance laser weapon systems debut aboard the USS Preble DDG-88 is a pivotal development in maritime defense technology, transitioning from theoretical concepts to operational capabilities. While much of the focus in reports centers on the system's functionality and strategic implications, several layers of nuanced content are significant yet often overlooked.
1. Multifunctionality of HELIOS.
The HELIOS system is not solely a hard-kill weapon designed to destroy targets. It also incorporates a sophisticated optical dazzler that can disrupt enemy sensors and reconnaissance capabilities.
This dual capability is critical,
as it allows for both physical destruction of threats and strategic counter-surveillance operations. The importance of this dual approach cannot be understated. It showcases a shift in military tactics where disabling an enemy's ability to gather intelligence or coordinate attacks can be as crucial as physically neutralizing a threat. This aspect reflects a broader trend in modern warfare that prioritizes information superiority and situational awareness over traditional firepower.
2. Integration with existing naval systems.
HELIOS's design for seamless integration with the Aegis Combat System enhances the overall combat effectiveness of naval vessels.
The Aegis system is renowned for its advanced missile defense capabilities, and coupling it with a directed energy weapon like HELIOS could redefine engagement strategies against multiple threats.
The operational synergy between HELIOS and Aegis is a critical advancement that emphasizes the need for interconnected defense systems capable of coordinated responses to rapidly evolving threats. This integration exemplifies how modern naval warfare is increasingly reliant on advanced technology to maintain an edge over adversaries.
3. Logistical advantages of laser weapons. One overlooked aspect of HELIOS is its logistical implications. Traditional munitions require extensive supply chains and resupply efforts, often limiting operational endurance during prolonged engagements. HELIOS, with its virtually unlimited firing capacity as long as power is available, alleviates many logistical concerns associated with conventional ammunition. This capability is especially vital for naval operations where resupply may be challenging due to enemy action or extended deployment scenarios. The focus on sustainability and resource efficiency in military operations is a significant trend that HELIOS exemplifies, potentially reshaping how naval forces plan and execute missions. 4. Challenges of deployment and atmospheric conditions.
While the reports celebrate HELIOS as a breakthrough in directed energy weapons, they often gloss over the challenges associated with deploying such systems in real-world environments. Factors such as power generation, thermal management, and atmospheric conditions can significantly impact the effectiveness of laser weapons. The Navy acknowledges these hurdles and is actively exploring solutions, which underscores the ongoing complexities of integrating advanced technologies into existing military frameworks. Understanding these challenges is essential for realistic expectations regarding the operational capabilities of HELIOS and similar systems. 5. International competition in directed energy weapons. The global race to develop high-energy laser systems is not limited to the U.S. The advancements made by other nations, including Israel's Iron Beam, China's claimed breakthroughs in continuous firing lasers, and Russia's development of anti-satellite systems, highlight the competitive landscape of directed energy weapons. This aspect of Helios's deployment indicates a broader strategic imperative for the U.S. Navy to maintain technological superiority in the face of rapidly advancing adversary capabilities. The implications for international security dynamics are profound as nations invest in similar technologies, potentially leading to an arms race in directed energy capabilities. 6. Historical context and long-term vision. The development of Helios has been a long journey, beginning with a $150 million contract awarded to Lockheed Martin in 2018. This historical context is often overlooked but is crucial in understanding the sustained investment and commitment to advancing directed energy technology. The Navy's long-term vision for integrating directed energy weapons across its fleet reflects a paradigm shift in military strategy, emphasizing the need for innovative solutions to counter emerging threats. The gradual progression from initial contracts to operational deployment demonstrates the complexities involved in bringing advanced military technologies from concept to reality. 7. Implications for future warfare. The successful integration of Helios aboard the USS Preble signals a potential shift in naval engagements, emphasizing the role of directed energy weapons in future conflicts. As adversaries increasingly utilize drone swarms and other asymmetric threats, the ability to deploy cost-effective rapid response laser systems could redefine engagement protocols. The successful testing of Helios against UAVs not only validates its operational capabilities but also serves as a harbinger for future naval strategies that prioritize adaptability and resilience in the face of evolving threats. Conclusion. The Helios laser weapon system's deployment aboard the USS Preble represents a significant milestone not only for U.S. naval capabilities but also for the future of maritime defense. While many reports highlight its technological advancements and operational readiness, it is essential to recognize the broader implications of this system, including its multifunctionality, logistical advantages, integration with existing systems, challenges in deployment, international competition, historical context, and its potential to reshape future warfare. Understanding these nuanced elements provides a more comprehensive view of Helios's significance in the evolving landscape of military technology and strategy. 1. Operational capabilities and multifunctionality of Helios. The Helios high-energy laser with integrated optical-dazzler and surveillance system represents a transformative leap in naval defense technology. Its dual functionality allows for hard-kill physical destruction of targets and soft-kill disruption of enemy sensors capabilities. This multi-mission approach enhances the U.S. Navy's ability to counter diverse threats such as drones, fast attack craft, and potentially short-range missiles. As Helios integrates seamlessly with the Aegis Combat System, it bolsters overall combat effectiveness, enabling coordinated responses to incoming threats and enhancing situational awareness through its advanced surveillance features. 2. Development timeline and strategic importance. The Helios program's timeline from its inception in 2018 to its deployment on the USS Preble in 2024 underscores the U.S. Navy's commitment to integrating directed energy technologies into its fleet. The $150 million contract awarded to Lockheed Martin for the development of Helios highlights the strategic importance placed on such systems to maintain a technological edge in maritime defense. As other countries including Israel, China, and Russia advance similar technologies, the deployment of Helios reflects the U.S. military's proactive approach to counter evolving asymmetric threats while ensuring cost-effective defense solutions. 3. Testing and operational readiness. The successful test firings conducted by the U.S. Navy's Center for Countermeasures demonstrate Helios's readiness for operational deployment. The ability to effectively engage unmanned aerial vehicles (UAVs) during testing validates the system's functionality and performance in real-world scenarios. These rigorous tests not only confirm Helios's capabilities but also guide future refinements and integration strategies. The Navy's commitment to advancing directed energy weapons is evident in the ongoing plans to expand the use of such technologies across the fleet, including the potential deployment of even more powerful systems like the 150 kilowatt Laser Weapon System Demonstrator (LWSD). 4. Challenges and future implications. Despite the promising capabilities of HELIOS, there are acknowledged challenges in deploying laser technology effectively in complex military environments. Factors such as power generation, atmospheric conditions, and the need for sustained energy supply impact the system's effectiveness. As the Navy grapples with these challenges, it is crucial to ensure that the development and deployment of directed energy weapons align with operational needs. The broader implications for naval strategy, international naval competition, and the future of warfare are profound, as the integration of high-energy laser systems could redefine naval engagements and enhance the U.S. Navy's ability to respond to contemporary threats in a rapidly evolving security landscape. 1. The Strategic Defense Initiative (SDI). Overview. Proposed by U.S. President Ronald Reagan in 1983, the Strategic Defense Initiative aimed to develop a space-based missile defense system to protect against nuclear missile attacks. It emphasized the use of directed energy weapons, including lasers, to intercept incoming ballistic missiles. Impact. Although SDI faced criticism for its technological feasibility and high costs, it spurred significant advancements in missile defense technology and shifted military strategy during the Cold War, leading to increased research in directed energy systems. 2. The Laser Weapons System Laws. Overview. The U.S. Navy's laser weapons system, operationally deployed aboard the USS Ponce in 2014, was the first laser weapon used in combat scenarios. Laws demonstrated the ability to engage and destroy drones and small boats, representing an important step in integrating laser technology into naval operations. Impact. Laws showcased the effectiveness of directed energy weapons in modern naval warfare, highlighting their potential for cost-effective rapid response capabilities and paving the way for subsequent systems like HELIOS. 3. The Iron Dome and Iron Beam systems. Overview. Israel's Iron Dome is a renowned missile defense system designed to intercept short-range threats, which is now being complemented by the Iron Beam, a high-energy laser system aimed at intercepting drones, rockets, and mortars. Impact. The Iron Beam system aims to reduce the cost per interception significantly compared to traditional missile systems, reflecting a broader trend in military strategy toward integrating laser technology for efficient defense against asymmetric threats. The development of Iron Beam underscores the global competition in directed energy weaponry, similar to the advancements made with the HELIOS system. The recent deployment of the HELIOS high-energy laser with integrated Optical-dazzler and surveillance laser weapon system aboard the USS Preble DDG-88 marks a pivotal moment in the evolution of naval defense technology, signaling a promising future for directed energy weapons (DEWs) in maritime warfare. As nations around the globe accelerate their investments in advanced military technologies, the implications of such developments extend beyond mere tactical advantages. Below are predictions for the future of maritime defense shaped by the emergence of systems like HELIOS. 1. Enhanced naval capabilities. The integration of HELIOS into the U.S. Navy fleet is expected to enhance its operational capabilities significantly. The system's ability to engage multiple threats, including drones and anti-ship missiles, will lead to a shift in naval combat strategies. Future naval vessels will likely be equipped with higher-powered laser systems, potentially scaling up to 150 kilowatts or more, allowing for longer engagement ranges and a broader spectrum of target types. 2. Cost-effective defense solutions. The operational cost-effectiveness of laser weapons compared to traditional munitions will drive their adoption. With virtually unlimited ammunition as long as power is available, navies will see reduced logistical burdens and increased operational endurance, particularly in prolonged engagements where resupply may be challenging. This shift could lead to a re-evaluation of defense budgets, favoring investment in DEWs over conventional missile systems. 3. Asymmetric warfare and deterrence. The rise of inexpensive drone technologies and asymmetric threats will necessitate a re-evaluation of naval defense strategies. HELIOS and similar systems provide a scalable response to these challenges, enabling navies to effectively counter low-cost, high-volume threats without depleting missile stocks. This capability is expected to deter adversaries who rely on swarming tactics using drones or small boats, thereby maintaining a balance of power in maritime regions. 4. Global arms race in directed energy technologies. As the U.S. Navy advances its directed energy capabilities, other nations are expected to respond in kind. Countries like China, Russia, Israel, and several NATO allies are also developing their own high-energy laser systems. This global arms race will likely lead to rapid advancements in DEW technology, including improvements in power output, targeting accuracy, and integration with existing defense systems. The competition may foster international partnerships or alliances aimed at sharing technological innovations and best practices. 5. Integration with autonomous systems. The future of naval warfare will see an increasing convergence of directed energy weapons with autonomous platforms. As unmanned aerial vehicles, UAVs, and surface vessels become more prevalent, integrating HELIOS-like systems into these platforms could enhance their defensive and offensive capabilities. This will allow for real-time responses to threats while reducing the risk to human operators, ultimately reshaping naval engagement strategies. 6. Technological challenges and adaptation. While the potential of high-energy lasers is significant, challenges remain concerning power generation, atmospheric effects, and the durability of laser systems under military conditions. Future developments will focus on overcoming these hurdles, possibly leading to innovations in energy storage and management, cooling systems, and protective measures for laser components. As these technologies evolve, their effectiveness in various combat scenarios will improve, solidifying their role in future naval operations. 7. Legal and ethical considerations. As laser weapons become more common, legal and ethical implications will arise, particularly concerning rules of engagement and the potential for collateral damage. International treaties and agreements may need to be updated or created to govern the use of directed energy weapons, especially in relation to their deployment against civilian targets or in densely populated areas. 8. Changing nature of naval warfare. The successful operationalization of systems like HELIOS may fundamentally alter the nature of naval warfare. Traditional battleship engagements may give way to encounters characterized by high-speed precision strikes using DEWs, necessitating new tactics and training for naval personnel. Future naval engagements may rely more on technological superiority and less on sheer firepower, leading to a rethinking of naval doctrine. Conclusion. The debut of the HELIOS laser weapon system aboard the USS Preble represents a significant leap forward in naval defense capabilities, foreshadowing a future where directed energy weapons play an integral role in maritime security. As nations continue to innovate and compete in this domain, the landscape of naval warfare will undoubtedly transform, bringing new challenges and opportunities that will shape global security dynamics for years to come. The proactive adaptation of naval strategies, operational doctrines, and international regulations will be paramount as the world enters this new era of maritime defense.